Hello, my name is Seth Art, and I'm a principal consultant at TÜV Rheinland OpenSky and the technical lead of our cybersecurity testing team. The two people presenting with me today are Brian Molinari, who's OpenSky's National Practice Director for Cloud-Enabled Infrastructure Consulting Services, and Brian Nolan, who's OpenSky's National Practice Director responsible for cybersecurity testing and threat detection services. TÜV Rheinland was founded 145 years ago as an organization that inspected steam boilers in Germany. Today, TÜV Rheinland is a $2 billion global organization that has over 500 locations in 69 countries and is a global leader in independent testing, inspection, and certification. OpenSky is part of the TÜV Rheinland group, and we help organizations master their risks, migrate to the cloud, build cyber defenses, and perform cybersecurity testing. This talk is about using the cloud for cybersecurity testing and whether that's a good option for you, either now or in the future as your capabilities mature. Regardless of how mature your capabilities are, the fact is attackers are currently using the cloud and have been for a while. This image is from the United States Joint Analysis Report released in December of 2016 that attributed the DNC hack to the Russian intelligence service. What I like about this image is the way it laid out the attack. In red, you have the adversary space, in gray, the neutral space, and in blue, the victim space. The main reason that neutral space exists is to help the adversary avoid attribution and to remain agile. And whether we're talking about state adversaries, lower-end adversaries, or offensive security professionals, using the cloud as your neutral space gives you a lot of that needed flexibility. If you look at any recent attack that publicly discloses indicators of compromise, and you look at who owns those IP addresses, you'll see that malicious actors are not just using one cloud provider, often they're using many. The big advantage that real attackers have always had over testers is that they don't really care about breaking laws or violating contracts. There were plenty of other public IPs in this list that were owned by corporations, universities, local governments, etc. We, on the other hand, are tasked with stimulating the adversary to help our defenders improve their capabilities, but we have to find ways to do that legally. We can use things like Tor or private VPN services, and that will help us avoid attribution, but mature defenders that use IP reputation services will flag that traffic and be in high alert. Cloud providers like AWS, Azure, Google Compute, DigitalOcean, they solve this problem for us really nicely. You can't really flag as a defender all of AWS or Azure as malicious, can you? That means that we can legally perform realistic adversarial simulation from a trusted place, and there's virtually no limit to the sophistication of our attack infrastructure. So we know attackers are using the cloud, and we know that we need to use the cloud once we're ready to perform certain types of adversarial simulation. But can you perform all of your testing activities from the cloud? How can you do that efficiently and securely? And what are the benefits of using the cloud, and what are some of the limitations? Those are the questions we're going to try and answer, and we're going to do that by talking about our own testing environment and our own migration to the cloud. So right now, what you're looking at is a basic diagram of our previous infrastructure. This is a rented rack at a co-location facility, protected by a pair of firewalls and set up with multiple zones, and accessed by the testers through VPN. While I certainly want to cover all of the cool stuff that we can do from the cloud, what you're looking at here is a very capable, flexible environment, and it met our needs for a long time. Really, the only problems were that it didn't meet all of our needs anymore, and that we had to rent more resources than we needed 90% of the time, just for the times that we needed the full capacity. So what drove us to the cloud? We needed something flexible and scalable to help us avoid attribution if needed and to remain agile. We were looking to reduce our management overhead. And lastly, like everyone, we wanted to see if we could expand our capabilities and do that while reducing our costs. So with our drivers in hand, we went to the experts. Brian Molinari and his team do this day in and day out. They help organizations define their requirements and help them migrate to the cloud when applicable. And that gets to the reason why I wanted to talk about this topic. In the event you are considering the cloud for your testing capabilities, I wanted to get Brian in front of you to share some of the knowledge that he shared with me and my team. So I'll let him take it from here.
Thanks, Seth. As Seth mentioned earlier, my primary responsibility at OpenSky is leading our cloud-enabled infrastructure consulting practice. But I also act as the OpenSky's CIO for our internal IT operation. Our IT staff provides basic IT ops services for our testing team. Specifically, for the previous environment that Seth shared, our IT team managed the relationship with the colo vendor, provided hardware break-fix support, and we also lent expertise and support for the design and configuration of all the underlying virtualization and network infrastructure. The previous environment that Seth showed, it served our team extremely well for the last 5 or 6 years. But along with the drivers that Seth mentioned, there were some aspects from an IT operations perspective that needed addressing. First, we were coming up on some needed infrastructure upgrades as some of the hardware and software and networking was beginning to age, and there were normal lifecycle timeframes that were kicking in, and that was going to result in some expense and impact on our testing team. Additionally, it was traditionally cumbersome to support new requirements and growth as it results in coordinating new hardware acquisition and on-site physical installation with the colo provider. Seth also mentioned the need to be able to provision for peak load, and in order, if we get a lot of requests for testing that come in simultaneously and need to scale up quickly, that tended to lead to us over provisioning the environment, so we end up with idle resources. Because we purposely run the testing environment as a standalone environment separate from the rest of the IT org, there was no way for us to share capacity. And finally, in our business, it's very helpful if we can assign costs directly back to projects versus carrying everything as overhead costs. And with the previous model, there was no real means to allocate specific costs back to specific engagements. So moving our testing platform to a public cloud infrastructure as a service solution not only provided a way to address our IT ops challenges, but it also resulted in some additional benefits for our testing team. First of all, there's much more flexibility for our team to independently deploy resources without IT involvement. Another benefit was, instead of just running in one location, we now introduced the ability to deploy workloads regionally, either across the country or across the world in different AWS data centers, which supports some of the attribution avoidance needs that Seth will discuss a little later. A cloud platform also gives us the ability to better segregate and isolate workloads without having to rely on complex infrastructure designs, and you'll hear a little more about that later. And then from a migration perspective, we were very quickly able to quickly and securely link our legacy environment to the new environment we were building out, do some validation testing, and once we were comfortable that things worked, migrate things over quickly. So cost and agility are always important factors for many cloud strategies, but one of the real values is gaining access to a rich set of cloud-native services that come built into the platform. The slide I show here depicts some services available on the AWS platform, but we could create a similar slide for other cloud providers like Microsoft Azure, who have corresponding capabilities, just with a different set of names. The important takeaway is that these are ready-to-use features in cloud platforms. And to get equivalent functionality in traditional on-premises environment, it often requires the implementation of additional platforms and tool sets, often at significant cost and complexity. We were able to leverage, for instance, AWS's Active Directory service for the testing team instead of standing up, building, and maintaining the underlying infrastructure components that come along with building out traditional Windows Active Directory. We still administer the AD, but we don't have to look after the underlying infrastructure pieces and patching. The information coming out of services like the VPC flow logs, Cloud Trail, AWS Config, and CloudWatch also give us a level of monitoring and visibility that we just didn't have before, and it would have required a lot of cost and expense in our previous environment to get the same capability. As a former network subject matter expert, one of the most striking differences for me to moving to the cloud is the ability to completely rethink traditional on-premise data center network design. Traditionally, the layer 3 network or subnet has been the focus of the way security boundaries are typically put together. In the cloud, even within the same IP subnet, workloads don't necessarily have wide open connectivity to each other, which is a good thing. The concept of security groups now dictates how workloads communicate with other resources within the cloud and with in the outside world as well. We no longer have to worry about which network to place workloads, only which security group we want them in. This provides the mechanism to achieve whatever level of network segmentation is appropriate for workloads. And Seth will actually go into a little more detail shortly about how this specifically benefits our testing team. From an IT ops perspective, moving the testing platform to the cloud was a big win. We were able to reduce our monthly costs by at least a third. Actually, I think we might be actually at a third of our previous costs, and that's going to differ for everyone. We improved our ability to better allocate infrastructure expenses directly back to consulting engagements. We increased the autonomy of our testing team to provision resources without IT involvement, and we improved the visibility of the environment without incurring large expenses. And there were also some nice benefits for our actual business as well. Anytime we can have additional use cases and knowledge to feed back into our consulting arm, we can help our customers adapt the cloud to their specific business uses, and having a real use case to talk about on our own is very helpful in that respect. And we've also provided expanded knowledge and awareness of cloud technologies to our testing team. Working with the cloud environment day in and day out has allowed them to add additional knowledge and testing capabilities back into their the way they approach serving their customers, especially customers with cloud-based environments. So I'll now turn it back over to Seth, who will talk about some of the specific testing scenarios and how the new cloud platform supports them.
Thanks, Brian. For the next section, I figured it would be fun to walk through some real activities that we perform, as Brian mentioned, from our AWS environment. And as I'm doing that, I'll touch on some of the things we've learned along the way as testers. The first example I'll talk about is performing a real-time phishing attack from our cloud environment. But before I do that, I want to address notifying your cloud provider about your activity. So as Brian mentioned, we chose AWS, and they have two separate ways to notify them regarding cybersecurity testing. If you're going to be performing vulnerability scanning, web application scanning and testing, or an announced penetration test, then that first email address, the penetration testing email, is the right place to go. Now, there's a separate email address for if you're trying to do things like avoid detection, or you're performing phishing, command and control, or other adversarial simulation activities. For that, you want to contact the simulated event team. Now let's move on to some of the fun stuff. A lot of people believe that multi-factor authentication protects against phishing, but it doesn't. What MFA does well is prevent someone from using compromised credentials. But if the attacker is able to phish the victim, the attacker can man in the middle of the MFA process in real time and gain access to the protected environment. Now, this is not a vulnerability. Rather, it's just a use case that most MFA solutions were not designed to protect against. And that part has been known for a while. And worse, there are public examples showing that this is being exploited in the wild. So we recently had a phishing engagement where the client was using Office 365, and all of the logons were protected with multi-factor authentication. My colleague wrote a tool that automated this process and allowed us to gain access to the protected environment through phishing. We've recently published a blog post showing how the attack works, and it includes a video. So let's take a look at the attack And then we'll walk through setting that type of engagement up in AWS as opposed to our previous environment. So what you see here highlighted in red is the victim's screen, and they have just been sent a phishing email in this scenario. Now highlighted in red to the right is the attacker screen. The attacker is on the real Office 365 site and waiting for the victim to click the link. So right there, the victim is going to click a link. It's a fake notification from SharePoint. And what you see here is for the phishing engagement, we cloned the real site, which is very traditional phishing. We put it on a fake or a different domain. And as soon as the victim enters their credentials into our fake site, they get sent not to the real site, but to the attacker. And we wrote a tool called MFA Slipstream, and that tool sends immediately those credentials to the real site. Now, MFA Slipstream also changes dynamically the screen on the victim side and asks them for their one-time PIN. So what happened is the attacker's machine sent the credentials to the real site, which is going to trigger that one-time PIN being sent to the victim. And as this comment states, they're being sent from the real Office 365 site to the victim. And the page looks legit, so the victim is going to enter that one-time PIN right into the attacker page. And just like the password was sent, the one-time PIN is also sent to the attacker. And now the attacker has everything they need to log on to the protected environment. So what we're highlighting here is that, again, with XHR and JavaScript, we're able to dynamically change the victim's page and tell them that an error has occurred. Now, back on the attacker's side, because this is Office 365, the attacker doesn't just have access to SharePoint. The attacker actually has access to all of the Office 365 properties that the victim has access to, so that Yammer, OneDrive, OneNote, Teams, anything that the victim was using. And the proof of concept wraps up right here with just showing you that in the OneDrive place the client had sent the information. And the last thing I wanted to call out here is that while this video deals with one-way SMS, so the text message sent, the tool MFA Slipstream and MFA in general is vulnerable if you use the Authenticator app in the Notify, where you get a pop-up that says approve or deny. Also, kind of the Google Authenticator type where you have an application that gives you that one-time PIN. All of these, and a voice call, all of these different MFA mechanisms are vulnerable to this type of phishing, real-type phishing. So now let's walk through setting up something like this in AWS. Once you've registered your domain name and gotten your SSL certificate for the attack, you'll need to stand up the Amazon EC2 instances that will be used for this engagement. And for that, to create the instances, we'll use something called an AMI, or an Amazon Machine Image. Now, there are a collection of community AMIs for many versions of Windows and flavors of Linux, and you'll most likely start with those. But what is nice is that you can customize your instances that you create from those community AMIs, and then make your own AMIs that can serve as templates. So we're now going to configure and launch an instance from our custom phishing server AMI. And to give you an example of some of the things that you can bake into your AMI or your template, this started out as a Ubuntu server, and it has a modified version of the open source tool GoPhish installed, and it has all of the team members' public SSH keys installed. So as soon as the instance is spun up, we can all SSH in with our own keys and gain access to our own user accounts. Now, the first thing I want to call out while we're setting up an instance is configuring our phishing server with a public IP address. With AWS, compared to your traditional setup, the NATing is completely abstracted. You don't have to create NAT rules. The web console will tell you what your public IP address is, and even though the instance only has a private IP address, that NATing just works. Now, as for allowing inbound access, that is done with something called security groups, which Brian mentioned, and which I'll touch on again now. So if you're unfamiliar with security groups from the attacker perspective or how this would work for us, but you're familiar with traditional firewalls, think about it like this. A security group is like a network-based firewall in that it's applied at the instance level. So I say it's like a network-based firewall because even if the machine is compromised, the attacker can't disable it, right? It's an external control, unlike a host-based firewall. But one of the biggest advantages, and Brian alluded to this earlier, is that because you're applying this security group, this security policy, to the instance itself, you can completely isolate instances from each other, even if they're on the same subnet, in ways that you couldn't with a traditional firewall. So the image here shows that I'm applying 3 security groups to this particular phishing server. I've applied our DMZ-based security group, and that allows a certain set of LAN servers to talk to the DMZ instances. And I've also allowed HTTPS and SMTP inbound for obvious reasons, considering this is a phishing scenario. So at this point, the instance has been launched, as you can see at the top left of the screen. And once the instance is launched, there's a really nice way to view the effective policy that has been applied to the instance. And it also helps me illustrate the power of security groups. So the chart that we're looking at now in gray shows all of the allowed inbound access, and it separates the allowed access by the security group that allows it. And as I mentioned earlier, what's noticeably absent from this policy is there is no rule allowing other instances in the DMZ to talk to this particular instance. We often have multiple engagements running at the same time, so we need to make sure that the default policy has that separation between those instances. So to wrap up this scenario, this is a list of what we still have to do. So we've launched our phishing server, and we need to configure our server with the domain and certificate. Then we use a second pre-configured AMI to launch 5 instances. Well, I guess I'll call that our Ubuntu bot, right? That attacker box that we saw in the demo. And you can configure all 5. You can launch all 5 of those just with one click. At that point, we can execute the campaign. Once the campaign is over, we can transfer off the relevant data so that we can write a report. And this is nice. Once the project closes, we spin down our entire infrastructure and terminate all the project-based instances, completely wrapping that up from a data perspective, which is really nice. So the second use case I'd like to talk about is how the cloud enables us to perform certain adversarial simulation engagements. Now, adversarial simulation still means different things to different people, but we view it as any activity that is not just about finding and exploiting weaknesses, but rather an engagement where the goal is to identify gaps in the organization's detective and reactive capabilities. Will the blue team catch us in minutes, hours, or days? Or will they catch us at all? Once we get caught, what reactionary steps do they take? Also, once we get caught, can we get in again? Things like that. When it comes to making sure your recon or attack traffic is sourced from the cloud, the good news is that you have plenty of options. And this is a question that comes up a lot when you first start doing testing from the cloud. Now, we have a split tunnel VPN into our AWS environment, and we gain access to our instances from there. So we don't allow any direct public access for management, although that's certainly an option, but that's not what we do. Now, once you've connected into the VPN, you could, of course, just SSH RDP or XRDP into your instances and source your traffic that way. But if you want to run tools on a non-cloud instance, you can still tunnel that traffic through your cloud environment with things like SSH tunnels and SOX proxies and things like that. Now, for an example, talking about how flexible our infrastructure or AWS can be, for each of our adversarial simulation engagements, this is one that includes phishing, we'll set up multiple campaigns and multiple backup C2 instances at the engagement start, just to avoid on-the-fly building if we can. Each instance has completely different public IP addresses, domains, and phishing alerts. That way, if one gets compromised, we can quickly switch to another. And that said, even though we pre-built this stuff, if you need to change things on the fly, you have a lot of flexibility. For instance, with something called elastic IPs, you can assign a new public IP to an instance to change that public IP on the fly. You can have some of your C2 servers, for instance, on a different region with a completely different IP space. And you can even have some of your C2 environment, your command and control environment, on a different cloud provider. So you can have some of your C2 on DigitalOcean, some of it on Azure, some of it on AWS, etc. Now, at some point during an engagement, you'll likely have to do some password cracking. You might already have a password cracker, a very powerful one on-prem, or you might not. Either way, having access to a fast password cracker in the cloud that you could rent by the hour can come in handy, and it has for us multiple times. Amazon has a few high-end GPU-optimized instances that contain anywhere from 1 to 16 NVIDIA GPUs. So if you don't have an on-prem cracker, sometimes after some quick wins with a cloud-based cracker, you might be able to have the ammunition you need to convince your management that it's time that you need a cracker of your own. And if you do have an on-prem cracker already, there might be times where you quickly need to crack a second set of passwords or password hashes while your primary cracker is in the middle of the first job that you're running. So wrapping up our adversary simulation use case, one thing that's really easy to do, as I kind of mentioned in the last one, is process cleanup. Depending on how your instances were created, you can often just terminate all instances that were related to a project with a few clicks. Also worth noting here is that if you have always-on infrastructure, as we do, things like Burp Collaborator, et cetera, there's also a termination protection that you can enable so that somebody can't accidentally terminate something with one click. But for the project-based stuff, it works out really well. So there's only so much we can cover in one session. But so I'm going to move through these last 3 use cases more quickly. That said, if you'd like to talk about any of this in more detail, our contact information is on the last slide of the presentation, so please feel free to reach out. Now, one question you might have is, should I keep my internal tooling on-prem and keep 2 environments, or should I move all of it to the cloud, to my cloud provider? And we decided to move it all to AWS, and it works great for us. I know of other organizations that have made a hybrid environment, so you really have a lot of options there. As Brian mentioned, we decided to use AWS Directory Services to manage authentication and authorization to all of our LAN resources. What's really nice about this is that we have a different authentication mechanism in our LAN and in our DMZ. That way, if the DMZ instance ever gets compromised, there's not only no way to get through in layer 3, but there's also no shared credentials or password reuse. So what do we have in our LAN? Well, basically all the stuff that we had in our previous environment. We have a private Git server that's set up to mirror some repositories from another internal to another server in our DMZ. We have our application security scanners, our vulnerability scanners, and the custom tools that we've created that automate some of our most tedious processes like vulnerability consolidation, report generation, and things like that. It all works just as good, if not better, than in our previous environment. So I certainly can recommend that approach. Moving on. So the next thing I have to talk about is using the cloud for your lab. Anyone performing penetration testing needs a test environment. And one thing that I really like about our AWS lab compared to our previous lab is that Windows licensing is just built into the hourly cost of your instances. Another great thing is that you can have access to multiple versions of Windows, again, really easily, and licensing is built in. So you can set up as many Active Directory environments as you like, and you can spin them up and down as needed. Now, I will say one limitation when creating, lab AWS environments is that, at least in AWS, is that there are no AMIs for, Windows 7, Windows 8, Windows 10. However, I will say in our lab, we just use Windows Server instances with just a few tweaks that make them simulate a client machine, and we're still able to do all of the type of Active Directory penetration testing and lateral movement and privilege escalation testing that we need to do. So after everything I've covered so far, I still haven't completely answered the question, what can and can I do from the cloud, from my cloud provider, like AWS? And let me end my section like this. With vulnerability assessment and penetration testing, you can absolutely do all of those activities from your cloud provider. Web application testing, you can absolutely do that testing from the cloud as well, but let me break it up like this. For testing publicly accessible applications and web services, this is an easy yes, right? They're publicly accessible, and your instances are, in the AWS cloud, for instance. Now, from going from the AWS cloud to a non-public application, like something that is inside of an organization, the answer is still yes, but you just need to gain access to that internal network first. You can use something like a site-to-site VPN, or you can even use a client-based VPN software like Cisco AnyConnect or Global Protect to gain access to the environment just from a particular AWS instance, and then do all your testing from there. Now, when it comes to mobile applications, mobile devices, medical devices, and IoT testing, now the cloud doesn't solve all of our problems here, right? It's kind of the way it's always been. Sometimes you just need to have something next to you to test it. Now, on the flip side of that, most of those devices use public web-based APIs and other types of APIs, and you can certainly test all of that infrastructure from the cloud. So with that, I'm going to pass the floor to Brian Nolan, who's going to talk about how we use some of the data that a mature cloud provider like AWS makes available to us to help protect ourselves.
Thanks, Seth. So from a threat detection perspective, cloud systems and services really need to be monitored just like other enterprise and operational technology. And that certainly holds true if you're going to move your cyber testing technology to the cloud, as we've been discussing. So what you're seeing on the screen is the model that we advocate, as the next generation of threat detection, which really is focused on taking all of your security data and logs and bringing it into a single centralized security data analytics platform and leveraging some of the emerging capabilities with big data, security analytics to perform continuous threat monitoring and threat hunting and leveraging things like machine learning and behavior-based anomaly detection and integration and correlation with threat intelligence to perform that advanced threat detection. There's a lot of compelling reasons to look at cloud-based centralized logging analytics solutions as far as scalability and performance and security assurance and cost reduction and some of those considerations. From our perspective, we use Sumo Logic, whom we're partnered with, as our analytics platform, which is a native cloud-based analytics platform. And then the next piece of it, which we see as really a key piece to being successful in threat detection, is aligning and integrating that detection with the organization's risk management program. So the way that we approach that is, it starts with prioritizing risk and creating risk statements as part of the organizational risk management program. And then from there, taking those prioritized risks for that environment and technology and understanding, what are the attacks, related to those risks and what are the activities of those attacks and how can we build efficient monitoring and detection, related to those activities so that we're really, focusing monitoring, hunting, investigation, response where it matters most to the business. these platforms can take in a lot of data, and we want to make sure that we're focusing on the data that's most meaningful from a risk perspective. So that's the overall model. When it comes to cloud data, in addition to all of the typical system and technology data, syslog and system logs and that type of information, the cloud service providers like AWS provide a lot of their own data as well. So here on the screen you can see that AWS has things like Cloud Trail and VPC Flow and Config and S3 and CloudFront, which are all feeds of data that you can consume. So I won't go through all of these, but I'll pick one example, Cloud Trail, and talk a little bit about how we build analytics around that. So Cloud Trail logs AWS API call details, which is essentially how we primarily interact with the AWS services. And some of the things that it logs are the identity of the API caller, the time, the source IP, the request, the response elements. And from there, we can start building analytics and data visualization. On the screen here, you can see things like geo-IP location of the users, so doing essentially geo-IP lookups of IP addresses and mapping them to a dashboard that we can view. We can build alerts around certain behavior anomaly. We can look at things like top administrative activities and activities over time and top users and recent activity, whatever is important from a risk management perspective. And on the next slide, you'll see that we can look at network and security data and events over time or in different ways as part of this as well. Really the key is aligning it to the organization's prioritized risk and building analytics that are meaningful to monitor. And this can be for monitoring and investigation. It can be building alerts for particular events or behavior anomalies that can kick off automated response and automated data collection for more investigation, things of that nature. So if you're interested in learning more about that approach, we're actually going to be doing a webinar later in the month of September, this month, of sort of the journey from how do you go from a prioritized risk statement to security analytics and monitoring, and we'll kind of dive into that a little deeper. And then one last consideration is if you're taking your own cybersecurity testing to the cloud and integrating that into a monitoring and security analytics platform, is if you're testing your own organization, you may not want security operations seeing everything that's going on from that environment. So you'll have some decisions to make about who should see, who should monitor that, and should it be the cybersecurity testing team that plays a role in monitoring that, so that you can do some of the red team testing without the security operations center having that visibility, or perhaps you decide to assign certain resources within the SOC access to monitor that environment with limitations on what they disclose to the rest of the team. So that's just something to consider as you go through it. And then one last piece is we have an OpenSky ebook available that goes into a little more depth on the threat-based approach to security monitoring as well.
Thanks, Brian. So thanks, Brian, and thank you all for watching. As I mentioned earlier, if you would like to talk about anything we covered with us, please feel free to reach out. All of our contact information is on this slide. So thank you all very much.